Hello everyone, let us solve the second question from today's bi-weekly contest, that is right triangles. So let us see what is given to us in this question. So we're given a 2D Boolean matrix grid. So Boolean means you're going to have 0 and 1 in the matrix, right? And now here what we want to do is very straightforward question. That is, you need to return an integer, that is the number of right triangles that can be made with the 3 elements of grid such that all of them have a value of 1. So now we have to consider all the cells with value 1, and using those cells of value 1 we have to create right triangles. And here they've mentioned how we have to, like, we're supposed to create these right triangles. So we have to consider collection of 3 elements of grid, and this is going to be a right triangle. Okay, and how is it going to be a right triangle? If one of its elements is in the same row with another element in the same column with the third element. So let's say this is the third element. With the third element you have the same one element in the same row as well as one element in the same column. So this is how a right triangle is going to be formed. So it can be formed like this, it can be formed like this as well, right? It can be formed like this as well, and it can be formed like this as well. Okay, so these are the kind of possibilities of creating the right triangle within this grid. Okay, and also remember this 3, right? So you have to consider 3 elements only, a collection of 3 elements. And then another thing that they mentioned here is that the 3 elements do not have to be next to each other. Okay, so it's not necessarily, they do not necessarily have to be adjacent to each other. Like these values, right, they cannot be adjacent, right? Let's say you have something like this. So you have something here, let's say a 0 is present here and another 1 is present here, a 0 is present here, another 0 is present here, another 1 is present here. Still, this one, this one, this one, right? So these also are forming a right triangle. So they do not necessarily have to be adjacent, right? So this is also how the right triangles can be formed. All right. So this is what is mentioned here. All right. So I hope now the question is clear, right? How we have to consider these right triangles. Okay. Now, how are we supposed to approach this question, right? So obviously, the first thing is to think of a brute force always. Okay. And in this question, I think if you have figured out the brute force solution, right? If your brute force solution is working for smaller values, then definitely you can come up with the optimized solution. Okay. So let us see the brute force solution first. Um, all right. So first thing is that in the brute force solution, obviously we consider all the possibilities, right? And we keep like iterating for them and calculating them accordingly. So here also we're going to do the same. Now there is only one catch here, right? That how are we supposed to like reduce our calculation or reduce the number of possibilities that we have here? All right, so let us see. So what we will do, we'll go and do a matrix traversal, right? And as soon as I come to this one, right, I already draw like some else here, right? So I can have some structure like this or like this or like this, right? So now the one can be placed here in this structure here or here or here or here or here, right? So if I set out and try to like write for all these possibilities, then you can see these are too many possibilities and will actually end up making our solution more complex, right? I'm talking of the brute force. But there is one hint in the question, right? The way that they have described the right triangle is that they're having this third element, and with this third element, they're comparing, okay, in the same column, you're supposed to have a 1, and in the same row, you're supposed to have a 1. So that simply implies that this is the one that we are targeting to, the third element, right? And this is the in the same row, same column, same row. Similarly, this is the third element that we are targeting, and this is the same row, same column. Similarly, this one and this one. So what is this? This is actually the center cell of the right triangle, right? This is in the center, right? From this, so these are the extreme, and this is the center. Okay. So if I focus on this, then I can definitely use this to my advantage. So what I actually do is I'll consider this as the center. And then you can see if I consider this as the center, the number of these conditions that I had to consider inside of my brute force, they are kind of reduced because I'm only considering this, right, center. Now then further be reduced if you simply draw it like this. This is your center. This is you have a 1 here. Let's say I'm just drawing it by my choice here. Alright, so let's say I have these ones here, okay? Now, I want to calculate how many right triangles can I form here. So obviously, this is fixed. This one is fixed. I'm saying this is the center, okay? Now the L structure, you can see all the L structures are already present here. This one, this one, this one, this one, you can form here, right? So consider all the possibility into one. So I formed this one structure, and using this one structure, I've considered all these possibilities. Okay, now let us see how we are supposed to calculate the number of right triangles. This was the first hint here, right? This was the first. That is why I'm saying the brute force solution is like the cue to writing the optimized solution in this question. Okay. All right. So we have this here. All right. Now I want to calculate the number of right triangles. Obviously, this is already fixed, and I have to consider the collection of three elements. So if let's say I fix this, right? So then how many number of right triangles can I make with this arrangement? These two ones are fixed, right? So I can have this one, right, to create a right triangle, and this, right? So I have a choice between these three. So basically, how many right triangles can I get? Three, correct? Similarly, with this one, if I fix this, right, this is fixed, this is fixed. How many number of right triangles can I form? Three. So how many times am I going to add three? The number of times these ones are present here. Okay, so how many ones are here? 5. So 5 times I have to add 3, which is essentially 3 into 5, right? So I am only considering the pairs of these. This is fixed. I know this is fixed, and I have to pair up these ones with these ones right here, right? So the ones that are present in the row and in the same row, and the number of ones present in the same column, right? So simply by multiplying that value, I can get the number of right triangles for this case, right? For this structure, how many right triangles are there? So this is how we can write a brute force, right? Now this was the second thing, that like the second important thing to write the brute force solution. So I hope this is now clear, right? How we going to calculate? So we are now let us sum it up together now, right? So we are going to consider this one. We're going to iterate inside the matrix, and we are going to consider while we are iterating in the matrix, we're going to encounter ones. So all those ones we're going to consider them as centers. Consider them as center. So from this structure, you can see I have only reduced it into one possibility, right? And one possibility is that I have to only get, and how we calculating the number of right triangles for this possibility? We're calculating the number of right triangles by getting the number of right triangles, number of ones in the column and in the row, okay? Excluding this particular one. So I'm calculating number of ones in respective row and column. Very sorry for the bad handwriting, but okay. So center and calculating number of ones in respective row and column. So this is what we are doing here. All right. So we are going to consider this as the center, and then we're going to go inside this row, this column right here. Let me draw the structure. This is what, so this is synonymous to this only. And here we're going to calculate how many ones we have in this column and how many number of ones we have in this row. And that we will be able to get the answer, right? That way we will be able to form the answer, because this, considering this one as the center, I can get all the number of right triangles. Similarly for this, I'm going to calculate the number of right triangles, and obviously I'll cover all the possibilities this way by considering this one as the center. All right. So I hope that is clear. Now, so if you look at the constraint, right, the grid size can be maximum 1000 into 1000, right? Now the brute force solution, what we are trying to do is, after we are at this particular one, so we are doing the matrix traversal, we are up to here, right, n cross m, and then for this, what we are going to do is, inside of this ith row and jth column, I'm going to calculate the number of ones, right? So I'll have two loops, right? Two loops here, and they will calculate the number of ones for this particular ith column, ith row and jth column. So basically another 1000, right? 2 into 1000, basically that is what we're going to multiply here. Now this will give you TLE, okay? This will not get accepted. So now we have to like optimize it. So now the optimization is quite easy, because we already have done the brute force solution. We already know how we want to calculate. Now we have to somehow get rid of this, right? Because n cross m will get accepted. I have to somehow get rid of this part, right? How am I supposed to get rid of this? All right. So what if I pre-calculate the values of 1, right? The count of 1 in all the rows and all the columns, right? So that is exactly how we're going to get rid of this. So we are going to pre-calculate the number of ones inside of that row and column, inside a respective row and column, okay? Not that. Okay, now let us form that, okay? We have R and C. So the number of rows, so this vector is going to have n length and this vector is going to have m length. So let's say n is the number of rows you have, m is the number of columns you have. All right, so here this is a 3 cross 3 grid, so the sizes are going to be the same, 0, 1, 2, and here also, right? So for the 0th row, what are the number of ones we have? Obviously for the 0th row I have one number of 1, so I'll fill it up like this. For the first row, this is the first row, I have 2. What is the third row? This, so I have 1. And what is the first column? Right, I have 0 number of ones here. Second column is this, 3 number of ones are present. Third column is this, how many number of ones are present? 1 number of ones is present, correct? So now I have formed these vector, I have pre-calculated it. So I'll do one matrix traversal to pre-calculate these values, right? Because I know these are going to help me get rid of that extra time complexity that I was getting to just calculate these values, okay? So now I know I have pre-calculated it. Now I have to go and do another matrix traversal, again treat it as the center. But now because I have pre-calculated the value, right, I don't need to go and iterate again and calculate the number of ones there, right? So I can simply take this. Now the catch with this is actually that here, right, for this particular column, let's say we have y number of ones here, so this particular one which is at the center is included here, right? Similarly, for this row, let's say we have x number of total ones here, so this one is including that. So if I want to calculate the number of right triangles, I simply take these ones, right, excluding this one, right? So this is what we take, correct? So basically it's going to be x minus 1, exclude this one, into y minus 1. This is how we have to now calculate. So this value we have to calculate, right? So this we can simply get from this, right? So now this is what? This is, let us do a dry run, okay? Then it will be clear. So let us take a count variable. So it's 0. So as soon as you are at 1, all the zeros simply ignore. When you are at a 1, you have to do the calculation as this, okay? And then add it to your count. So now this one I am treating as the center. So if this is the center, how many right triangles can I form this as this one as the center? So if I visually see, there is no right triangle I can possibly form with this as the center. Okay. So let us see if this can help us give the value 0. All right. So it is in the 0th row and the first column. So go at the 0th row and the first column. So now take what is at the 0th row, 1 minus 1 into 3 minus 1. So basically this will actually make this value 0, right? So now you can see this as the 1, this as the center. You're getting 0 number of right triangles, right? So visually also we saw 0 number of right triangles we are going to get. All right. So we'll add 0 to the count. Now move ahead, go to the next one in your iteration. Keep iterating the matrix. Ignore the zeros. As soon as you come to the 1, calculate something. Now how you're supposed to calculate for this? This is present in the first row and first column, right? So this value and this value you're considering. Now again put it here. So you will get 2 minus 1 into 3 minus 1. So what is this? 1 into 2, basically 2. Now add it to your count. Now your count will become 2 when you will have this one. So visually you can also see here, this is the first triangle and this is the second triangle that you can form with this one as the center, right? And similarly for this one, if you will see, this is the third column, so the value is 1 here, which means 1 minus 1 is definitely going to make it 0, and you can visually see, having this as the center, there is no right triangle that you can form. Similarly for this, no right triangle can be formed having this as the center. So that means you're going to add 0 to the count. So by the end of all the iteration, after you have encountered all the ones in the second traversal, you will have calculated the number of right triangles and add it in your count. Okay, so now you can return this. And that is going to be your answer. So I hope now the solution is clear, right? So this is what we had to like do here. And after like going through this, I hope you will be able to write the code, but let us go ahead and see the code here. The code is easy actually. So you have n, the number of rows, m, the number of columns, and then you have the count value, okay? And then you are creating these two vectors, right? So this PR vector is actually the R that we made before, and PC is the C which we created. So these are going to pre-calculate the number of ones in the respective row and column. And then here we are creating these vectors. This is the first matrix traversal to create PR and PC. After this, do a second matrix traversal, and in this matrix traversal you can see we're calculating the value here, right? So this is x minus 1, y minus 1, and this we are only doing if see, we need to have a 1 at the center, right? So whichever cell we are at, it should be a 1, right? So only then I can consider it as the center. So now I hope this solution is clear. So after this you can simply return count. Now let us discuss the time complexity for this. Obviously it is going to be bigger of n cross m, and space complexity is going to be bigger of n plus m because you are using the two vectors. So I hope now the solution is clear.